Hello Physics Nation, my name is Nate Larmond, and I'd like to talk about resolving vectors into their components. It's a really common calculation in physics class. Let's say, for example, we're going to try to add this guy, vector A, to this guy, vector B. The trick is you just break up each vector into its horizontal and vertical components. So, looks like some fancy equation. It's not. It's just SOHCAHTOA rearranged. This is cosine equals adjacent divided by hypotenuse, except we've multiplied both sides by the hypotenuse. So check it out. The horizontal component is a sub x. That's the adjacent side, according to this angle theta. And a is the hypotenuse. So if you do the hypotenuse multiplied by cosine of theta, you get the adjacent side. Likewise, this is SO in SOHCAHTOA, S-O-H. Sine of theta equals opposite divided by hypotenuse. The opposite leg, in this case, opposite to theta, is the vertical leg. And so, again, we just multiply both sides by the hypotenuse, A. So you get hypotenuse times sine of theta is the opposite leg, or the vertical leg in this case. Anyway, hit the buttons on the calculator and make sure you can do it. This angle right here is 20 degrees. Here's our given information. 12 is the length of the hypotenuse, and 20 degrees is this little angle here in between horizontal and vector A. Like I said, hit the buttons on the calculator. For the Casio, you do 20 cosine multiplied by 12. Make sure you can get this. In the TIs, you type it just as it's written here. Hypotenuse cosine 20 close parentheses, and you should get this. Make sure you're in degrees, not radians. Alright, so another way to view this is in Inventor. So let's open up a new part file. Come on, Inventor. Whoops, I opened up a couple part files. That's fine. Right click, new sketch. Let's do the XY plane, and let's draw a right triangle. So I'm going to choose the line function. We're going to start at the origin. We're going to come over here, and then we're going to close our triangle. There's the green snap. Alright, so we're going to right click and OK. I'm out of the line function now, and now we right click and let's see, show all constraints. Project geometry. This line is horizontal. This is perpendicular. We also have some coincident constraints. This little yellow dot means the end of the horizontal line is the same as the beginning of the vertical line, so these 2 points are coincident with each other. Anyway, I'd like to add some dimensional constraints. So what we're going to do is we're going to click this icon right here, General Dimension, and I'm going to click on the hypotenuse, left click again, and I'm going to make it 1 inch. I simply type 1 and enter. There you go. So our hypotenuse is 1 inch long. Now I'm still in the dimension constraint. You can right click and get out, or you can hit escape. But what I want to do right now is dimension this angle. So we're going to hit the dimension, we're going to click this line, and then the horizontal line. Alright, so left click, and I'm going to make this 60 degrees. Type 60, hit enter, and there you go. Why can't I move this thing? Let's see here. Whoops, yeah, no. Edit the sketch maybe? Here, now I can move it. Alright. Let's right click, edit the sketch. Okay. I just wanted that 60 degrees actually inside the triangle, and apparently you can't do that until you finish the sketch. Then you can grab the dimension. Anyway, I'm back. I right clicked over here and went back to edit the sketch. So, we have the length of the hypotenuse. We have the angle right here, 60 degrees. And check this out. I'm going to hit the dimension again, and I'm going to hit this line. Alright, this horizontal line. Let's dimension it. I click, oh, and I get an error message. adding this dimension will over-constrain the sketch. So what I'm asking the software to do is, I'm saying, I want to define the number that is the length of this horizontal line, except the software is saying, no, no, no. The length of this horizontal line has already been defined by these two dimensions. And so you just click Accept, and there it is. You left click. It's called a driven dimension. It's in parentheses to make it look different. It's a driven dimension. It is driven by these two constraints, the length of the hypotenuse and this angle. Well, this is the adjacent side relative to this angle. And that's the point of this exercise. If you know the length of the hypotenuse and the direction of the vector, 20 degrees for example, you know the length of the horizontal component, the adjacent component, and you know the length of the vertical component. Anyway, in Inventor they're called driven dimensions. So let's do the same thing on the vertical leg right here. We're going to, am I already in the function? Yeah, I'm already in the function. So I click on the vertical dimension, I get the same error message. It's a driven dimension, that's cool. 0.866, or as the math teachers like to say, root 3 over 2. So hit the buttons on the calculator. You're obviously not allowed access to Inventor on May 7th. So practice this on your Casio or your TI. It's really simple. On the Casio, you just hit 60, sine, multiplied by 1, and you will get 0.866. So you do the angle, you do the trig function, and then you multiply by the hypotenuse. Or you could do 60 cosine multiplied by 1, the hypotenuse, and you will get 0.5. Anyway, what we're going to actually submit is a snip, a screenshot of this. So let's finish the sketch. Let's push this over here so I can see my frame of reference. Let's hit my snipping tool. We do new, snippet, right click, copy. Here's the assignment description, but you're just going to paste it in your own document. You know, right click, paste. You can change the size if you want. Anyway, do the 4 famous triangles we use all the time: 30, 60, 90, 45, 45, 90, and 3, 4, 5, please. Thanks for watching, and I'll see you in the next video.